So hello, please let me know if you can hear me. Post plus, minus if you can hear me, if everything is fine with the audio video. Is it okay with the audio video? Plus, minus. Okay, so yeah, we'll wait for everybody to join up and give some feedback in the chat, and then we'll start. So I see one person saying that's okay. 2, 3, 4. So wait probably a few minutes before starting properly. So last time I got feedback from a couple of people that it was difficult to implement like basic mathematics in Python, and you had like serious issues with that. So that's why I decided to this time to focus more on the mathematical part with some simple examples using robot arms. So again, something very practical, like a game before. Now we're just with the robot arms. So like in Tesla factories or whatever, like in background with those mathematics, the quite similar stuff going on with what we will do today. So I see also here, hello, before I start, I have a question. Also, I noticed our homework that we sent has been graded. So if you will send the homeworks later, it will be okay as well. So I will not penalize those late works. The only problem is that they will get more and more complex and more like larger and larger. So if you just leave them alone and try to submit later, it will be much harder for you. So I would advise to try to not delay that too long. That's my only kind of advice in regards to that question. But yeah, I need to grade them just because I want to show before we start every time who are the best students and who are leading the pack. So today we'll start doing that. So here you can see, the top 10. Like the top 2 people is Betty, Rudzita, Gins, Jasmons. Then some of you are lagging behind, and then there are a lot of who are really lagging behind. So really hoping that you will catch up very soon. Otherwise, as I say, like I would not be happy to like fail people, but like this stuff is kind of like groundbreaking, you know, like if you know how to build these deep learning models, you're set for probably for your life. I mean, like maybe not, but let's say everybody wants proper deep learning scientists right now. So at least you should get over 50%. So please try to do those tasks. Now they are like baby simple. So then the best homeworks. So the GINT was implemented game like this. So he did the algorithm for the circles, the bouncing, the navigation. So again, like those who submitted the homework, there was a problem that they rotate the spaceship not around the center of the mass, but around some arbitrary point on the bottom part of the spaceship. So that would be great if somebody solves that when you submit the homework. And the best homework was, of course, for the VeA. So look at this, so really beautiful work, like also that she made that you can shoot the rockets, and there all of these non-symmetrical asteroids. Of course, there were some problems. She was trying to make it really precise. Maybe I will actually show it just in a second. And these asteroids were like she wanted to, so that they collide with very precise border to the edges. So that's not necessary. So if you just make your homework in a way that it it would work with some collision, like just from the center of the mass. That is fine by me, so you don't need to make it totally great. So here there's this VeA work, so you can see that it's rotating not around the center of the mass, so that's not optimal, but the scaling matrix is a proper order. Like it was not implemented like exactly like I would like, but still it's great that you got the result. And you can shoot the rockets. See, that is beautiful. So this is what I expect from every session, that you do the homeworks and do them well. So if you have questions, then try to formulate them as precisely as possible. If you just say that I don't know how to implement equations in Python, that is like not really a good question. You should like have exactly what kind of equation do you don't understand, like where there is a problem, bug, or whatever. So this is the thing that she sent, and let me show you today what we're gonna do today. So today we'll have really fun experiment, and also mathematically sound. So here, like you saw that the robot hand, so it quite quickly jumped to this. So okay, let me show you. So this is a robot hand with the two segments, right? And it is trying to reach that red point. So if I click at any place, it will try to change the angles and try to reach that point where I pose it. So even if the hand would not able to reach it, it will still try to do this. So especially right now, see, it's like trying to like change the middle angle and slowly approaching that point. So it's so I'm not sure, like so let's try out something. So while you look at this beautiful animation, so are you familiar with forward and inverse kinematics? Let's say inverse kinematics. So the inverse kinematics is something that you probably should be familiar if you have done any time like something with robotics. So if you have tried some Robot Studio, ABB or something, you should have done it. If not, like if you want to do something with robots, this is a basic math approach to solve like these problems, and they can be actually used in many other cases. So you see, it's quite fun to look how this robot hand tries to find the position. So I made a small script for interacting with the plot. So that's going to be for today. But okay, while we wait for the feedback, what I want you to do is first, so I will press escape. So with escape you can quit. I just realized that I would like to help out you a little bit, those of you who struggle to do the previous homework. So I will not definitely do everything for you. It's like that is, I think, in my opinion, useless way. So I will just show more with regards to navigation of the spaceship. So I see nobody actually have done any work with the inverse kinematics. So this is robot arm control and stuff like that. So we'll do that today. And let me then use the template that we started doing last time. I will quickly find which one was it. And please also you yourself also get ready to work with the spaceship game that we started last time, and and those of you like who did it correctly, you can maybe fix your problem with the like center of the mass for the player. I think none of you fixed that problem. So okay, let's see. So we'll start showing you how to make the way that the spaceship navigates, but you will have to do other things yourself anyways. Not show everything, but only some parts. So let's see, which part did they actually use the last time? Kind of funny that I cannot find it. Just a second. So many files. Okay, so I guess this one. So the translations and the rotations are here. That's fine. So scale matrix I will not show you. So let's go then to implementing the flying part of the spaceship. So let me check how far did I get with this code. So right now, so it is translated, but it's not rotating at around the correct place. Let me check. Maybe I was coding something, and so there is a so the scale matrix, right? Then we have the rotation matrix. So so it should not rotate around so it should be just translated. Just a second. Scale fine. Combined here, rotation matrix. When I change the angle, it changes rotation matrix. So it seems okay. The translation is the position. Yeah, I moved it 5 units to the right, so that's fine as well. I think there is something. Okay, I know where the problem is. So I guess maybe that could be some, but like those of you who submitted the homework found it yourself. So when I was coding this last time, I did not run this code, I just coded it. So you should have different order for these things. They should come in this order. Like you start with the matrix of which you want to add, like with the dot product, just multiply and sum, and then use the combined matrix at the end, like that. So, and then it should work. So if I run it again, that means that I should always try to run it first. So now it rotates here, so that's fine. But if you look, it rotates around the bottom part of the. So let me show you what I mean by that. Just a second. So like that, and if I just load this thing up, so see, it rotates around the bottom part of the triangle, the spaceship. So it do not rotate around the middle of the spaceship, so that not around the center of the mass. So we need to fix that as well. So we'll fix that quite quickly. Just a second, I will show you what I mean by that. So here, we also need to apply scale matrix, by the way. So if I press escape, it should exit. And what we want to do is to not rotate around this point, but around this point in the middle of the center of the mass. So that is what we want. And we also want to scale it a little bit. So okay, Armand is asking about some stuff regarding the translation matrix. Okay, I will cover that in a second. Just so let's see in the Jamboard, in the slide 2, I will start adding the stuff. Okay, so regarding the translation itself, so the translation is coming from here. So now the translation is from the position of the player, and here it is calculated just from the position vector here. But of course, we want this player to be flying, so let's move the translation matrix down here. So you could probably make your own function for translation matrix update, as there is for the angle, for example, but we'll be fine like this. So we move that to the draw, the translation matrix, and here the position is now set to the 5 units to the right, so we'll move it back to the 0, 0, like that. I also would like actually, okay, I will keep it like that. So I saw that some of you use this cool syntax of using the dot product with this and symbol. So I just want to test out, it should work as also with this one. So with this one, maybe we can write the equations a little bit nicer. So here there is the rotation. And as soon as this will work fine, I will copy that to the Jamboard as well, so you can follow up. Just a second, we'll test it. Yeah, it works fine. Okay, great. So either you can use the np dot, or later also with the torch dot, or use this syntax with the overridden operator of the and symbol. So, okay, so far like this, but let's leave it like this, and then we'll, in a second, implement also the movement. So we will copy this in the Jamboard, so you can follow. If you need some specific line or some explanation for specific part, then please let me know. I can scroll to that place, as Armand asked about the translation positions. They are coming from the position vector, so that's great. Now the other thing is that we want to use is the direction vector. So direction vector is something that is predefined, so in which direction our kind of this spaceship is pointing to, right? So we need to know that because we have the angle stuff happening there, so we want to use that part as well. So here we can actually calculate the direction. So right now the direction is the same as initial direction, but we want to change it, of course. So to change it, let's do the following. So again, vec3, so this will be three-dimensional. Then self, I mean not self, there is a vec2d to 3d, right? So this will be the self-directional direction in it. So this will be initial direction, and then we'll do the again the dot product. So this will be the again vec3. This will be the self R matrix that we have already. Then we will rotate it around the initial direction. Then we'll get the self vec direction, I mean not vec direction, but just direction, vec 3D to 2D, so it should be fine. So now we rotated our unit vector of the direction to the correct angle, so with these three lines, so that's great. So that's part done. Then we need to update the movement, basically. So I will not probably implement the bouncing and all that stuff, because you can do that easily yourself. The one, like, I'm not doubting your programming abilities mostly. Maybe I will just in a second test what you said last time, that you're great at Python. I mean, like in the first time. I have in mind some tricky samples for the Python. So here, or maybe next time, so we have a lot of stuff to do today. But anyways, if you want to see tricky samples of the Python, I will provide them later. So here there will be the position update. So we want to update our position, and we want to use the vector of direction, so self-direction, and of course we want to use the speed, so self-speed, and it should be fine. So I'm not sure, maybe it should be fine. So at least for the movement, now we should start moving, hopefully. Yeah, we're moving, right? So see, like we had to just add about like 5 lines, and now we have flying spaceship. So you should do that yourself as well. So let me add those lines to the Jamboard as well. So I will add those lines to the Jamboard. And now we also need the uh, translation to the center of the mass and the scaling matrix. So those two are missing now. Let me check. Did I implement? So I added to the Jamboard all of this stuff so far. The scaling matrix itself is not implemented here. I don't want to implement it for you, so so you need to do that yourself. But what I will do now is to help you out with the centering in this with the center of the mass. So to do that, that's again quite a trivial, simple task. So let's add this again here. So it will be the TC. So this will be the translation to the center of the mass, and this is going to be the translation matrix. And with the x-axis, we don't need to change anything. Dx is 0. Dy is minus 0.5, I think. So let me check. So what is our geometry? Geometry is, where is our geometry? Character, player. Okay, it's 1, right. So that's fine. It should be to have the center of the mass like that. Okay, so that is cool. Then the next part is we need to apply it. So to apply it, I would prefer, yeah, it's actually not that important. We can, no, I would prefer to copy it like that, and then self C is the self S. This will be the scaling that you will implement yourself, and then the C like that. And if I run it, it should work quite fine, hopefully. So let's see. So now, if I rotate around the center of the mass, not around the lower part of the triangle. So already we chained together quite cool list of matrices. So I will also copy this part to the Jamboard. Actually, maybe I should just copy all of these lines together. No, I will just copy that one. Okay, so my question will be in the chat to help following. So are you, is the spaceship flying for you? And if you submitted the homework before, did you fix the translation to the center of the mass? So this will be my question in the chat. So is the spaceship flying for you now? This is 1 plus minus, and for those of you who properly did the homework, then is the spaceship rotating around the center of the mass. By the way, for the homeworks, I also like reduce a little like the markings if you don't complete all of the tasks that are required. So if you post minus, then you can like ask like maybe post some fragment of the code or what is not working or error or whatever, so we can help out each other. So I see now 2 pluses, 1 minus. Let's wait for others. So if I go to the Jamboard, so you see here are the fragments of the code that you can add to your own code and make it working. And we'll wait for more people to be ready with this task, and then we'll move to the next task. Again, just a small reminder, when we started this course in the first workshop, I specifically mentioned and showed you the examples that the deep learning models, they are not about the programming and the coding as much as they are about the mathematics. So at this moment, we are kind of we need to dive in all of these things, feel comfortable about them. That's why I'm still pushing with the basic material, and today we also have this basic material with the robot arm. Hopefully that will also help you to be more comfortable with the all of the matrix operations that will be a lot in this course. So now we have 3 people pluses, 1 minus. So what about others? Are you all given up? So please let me know. Otherwise, I don't know if should I continue or wait for you to catch up. So please please let me know in the chat with a plus or minus. Are you ready with this work? If you're coding it, maybe you can just type in that working on it, or so then would know. Thank you for feedback. Emil's saying that it's working on it. Hopefully Armand's also working on it. Yeah, so we'll wait a few minutes, and then we'll move to the next task. So let's double check where is the status. So let's see. So what is the status? Working on it, done, or fail. So let me just type in like working, W, done, or fail. So if you just can copy in the chat one of those, then I know what to do next. By the way, the good news is that while you were working on this, I managed to make another small example of the Python interesting stuff that we'll see, like that I want to do experiment with you together. So please answer on this one, and then we'll move to the next tasks. We have quite fun tasks for tonight. Hopefully we can do all of them and not sit on these. So okay, one person working. What about others? So I think like if you will still be working on it for let's say, so please do not implement now the asterisks. Only if you've done this and then you can want to finish your homework and you did not do this in the homework previous time, then you do this. But otherwise, if you're done with moving spaceship, please post it D, so I know that that we can move on to the next task. It's just to help out to start you with the other tasks that you need to do. So because like I cannot just code everything in front of you. It's like these are quite trivial stuff that I already like given you last time some examples, this time examples. So now if you put all of this together, you should be able to finish all of the other parts. But right now I'm just waiting for the moving spaceship. So I see that 4 people are still working, and I think at least 3 people are already done with this. So I will give like 5 more minutes, and then we'll move to the next task. And hopefully we can squeeze in today the other part of the mathematics that we need to cover today. Okay, great to see that at least 2 people already down with this. Hopefully others will also can catch up a little bit later because all the stuff is available. So now let's do other couple of fun things. So let's do a quick survey again. So how well do you know Python? So I remember that. So from 1 to 10. Remember, like a few like the first session that we did, a lot of you said that you know Python at 8 and 7 and 9, and like only I think the one person was giving the 2 or something, and then we did some of the very basic object-oriented examples, and then we discovered that that those of you who said 8 were answering a little bit wrong. So I just want to do a quick survey of how well do you think you know the Python, and please type in the chat your evaluation. So I see Armand is typing in 1. So I just want to see those guys who said 8 and 9 in the very beginning, what they think now, and then we'll do a small test, and then we'll see what do you think afterwards. So we see 2 1s. So I think like the one thing that I learned is that if like the smarter you get, the you think you don't think you know everything. You think you know less than you thought in the beginning. So we're getting smarter. So that's a good point. So we see that we're getting smarter because we see at least 3 people evaluating as 1. So there are 1 5 1 6. So we'll see. Just a second. Meanwhile, I will prepare the small example that I will use for evaluation of your knowledge. Very simple one. Very simple one. Again, with the very simple samples, we can see. I'm generally not a fan of Python syntax. Yeah, I would agree. Like the tabs are really not nice. But for the mathematical libraries, this is the best we got. Like I would not prefer MATLAB or something for doing all of this complicated math stuff. So now I see like 12 people watching, but only 1 2 3 4 5 answer giving me the evaluation of their knowledge. Please, if others can also post in what they think from 1 to 10 their knowledge of Python at this moment, and then we'll do a small test. Please, that will be fun. Post in what you think. Like I remember in the first session, there were a lot of people saying that they know Python at 8, at 7. So it's just like if you post 8 or 7 or 9, I will not be offended. It's just like a fun test. Okay, I cannot get you do stuff, so anyways, it's in your own benefit if you type in stuff in the chat and interact with me. In that way, we can do these sessions a little bit better. And also, you can type in questions as you did before in the beginning of the session, and that also helps you because I can give you the answers in the live session. Later, I cannot do that. I can just maybe evaluate your homeworks and give some few comments. So, still, let's wait for one more. Okay, Armand is very smart guy. He at the same time I'm not sure like why he evaluates himself so low on Python. Maybe it is the truth. But what about others? Please, let's wait for another one evaluation of what do you think, and then we'll do the small example, and then we'll start working on kinematics. Still waiting for the answer. So I know that remember that there were Martins. I think he was quite knowledgeable about the Python. Maybe some other guys. So definitely VeA and others. Please let me know. Again, I will ask you again. So 1 to 10. Okay, if we will not get any answer, then we'll do anyway the task. Okay, 5. Okay, good. Thank you, Martin. Okay, so let's see if you're worthy to 5 to 6 to the best ones. So again, the new task for the Python. So please type in the chat the what will be the answer for the line. So the type in answers in order. So what order? So in what order you will get the so for example let me help you out. So here are the default parameters, right? In the Python, you can pass the like with the A like this. You can also not pass it at all like that, right? So it would still work. If you are good at Python, you know that. So and you see here this is a 2, right? Then if this is not larger than 2, then I add this 1, and for the first output should be 3. So please type in like just looking at this example, not coding it. What do you think will be the answers for each of these lines in the chat? So if you will code it, that will just be if you code it, then if you code it and then answer it, then you'll need to explain me why the answer is as it is. But it'd be great if you just give your opinion with with numbers. So it will the answer should look like 3 and 1 and 2 and 3. So just a small example about the Python. I have a lot of them like these. So type in the answers, please. Like for those of you, especially I would say like those of you who rate them as 5, 6, and above. So then just type in. And also the Kristaps is asking question, and that's great. If you don't understand the code, that is also a great question. So these curly brackets I mentioned in the first session, actually them. So they are dictionaries. So dictionary A, for example, we can have curly brackets and having all sorts of variables here. For example, C would be 2, for example, and then let's say some kind of Z can be 5, and it can contain all sorts of interesting stuff. And then you can pass this dictionary actually as parameter like this, or use the function there. So yeah, please let me know the answers. So I like that some of you are looking at the code and evaluating it, not running it, and giving me the answers. So that's what I want to see. So I got in like 1, 2, 3, 4 answers. That's great. So now if we will run it and quickly test it. So if I run it here, you will see that the answers are actually 3, 3, 4, and 2. None of you got it right. So in general, like I don't want to make you feel bad, you know, like about your knowledge of the Python, but in general, like it's not the Python. There are so many caveats. And this is just one of a lot of them. So you think you know what's happening there, but you don't know what's happening there. So the answer here is the first one, of course, is 3, right? So then the next one, we'll see that is like the coming in, the A is 3 here, so that's bigger than 2. That means that we put C as 0, and we say that this is 3. So, okay, and by the way, this question is completely related to the pointers that I showed you the last time. So here, and then in the next line, the 2 is not larger than, like the A is not larger than the 2. That means that we skip these lines for the third example. For this example, we skip these 2 lines, so it's not true, right? Then the next line here, we give the B our own variable with a C of 2, so that means that there will be the answer of 4, right? And then the next line, you would expect that there would be like the same output as this line, right? But this is not the case, because the Python is nasty. There is a lot of things with the pointers. So the default parameters are also pointers. So if you override any default parameter in Python that is not the basic data type, you override their memory in the heap memory. So this line, actually, the line 6, is not like some kind of automatic copy of the data, but it is a pointer to the memory. And you just overrided your own like this pointer here, and you got a serious problem here. So the output will be here will be 2, because the BC now is overridden in the memory, and this happened actually in this line. So a problem here, overridden memory. So I'm not sure, like, do you learn Python in the university? Hopefully these are some of the small things that are in the Python, but actually this would be the same also in other languages. So this is not actually specific to the Python. There are even more specific things. So again, let me ask then the next question: how you could rewrite code so that we would not override memory and have have default parameter, but keep default parameter. So do you have any ideas how to rewrite this code? So those of you who are again rated as 5, 6 and whatever in the Python, you should be able to rewrite this function in a little bit different way, so that we can execute this code and get the expected results. What do you think? Like, can you please share your ideas, or you don't have any ideas? So let's see. No ideas would mean minus. So I will let you answer on this one. Again, I think those of you who feel comfortable with Python with 6, that would be a fun question now to ask you. What is your confidence now? Maybe lower, but basically, maybe some ideas how to rewrite it. You should be able to do this. This is not that difficult task, but okay, I will help you out. And also, if there are some questions, you definitely can ask the questions. I'm happy to answer and help you out. So we can create a copy of the pointer default parameter. So that's an interesting approach. So if you create a copy of the pointer, you don't create a copy of the data. So there is no such thing as, there is a thing copy of the pointer, but that will not help at all. So the one thing is that you can copy the data itself, of course, like using some kind of, let's say, serialization methods, like just copying the memory segments, or converting to the JSON and then back to the data, for example, and stuff like that. Do not touch the dictionary at all. Just just add new variable dict inside the function. That's not a bad idea with a dict inside the function. So I think that's quite close, but let's wait. Maybe somebody have idea how to actually code it properly. So if you're saying that you would add a new variable, that might be a good idea, but we still need to have the default parameter. So how can you pass the default parameter to your function? So what I mean is that I still want that the line 10 and the line 11 works. So I want that, but I want also that I can have the line 12 to be working, and then line 13 would have the same output as line 10, not like right now. So if you write code like this, then really crazy stuff. So I know I have seen. So anyways, the one thing that also I like always to add in the code is if you give like some parameters without the variable names, I also like always to add it like this. So it make it readable, but still it will not help the problem. So do you have any ideas about solving the problem? Basically, you can solve the problem in like one line or so. Okay, I saw one minus. Others gave some ideas. Do you have any other ideas? Let's write down. Any other ideas or code snippets? Snippets. Do we have them? So minus no ideas. If you have questions about the code, you can write questions as well. Okay, so see one minus. Okay, anyways, so the way how to do this properly, again in any language, so is to have here the non, and if b is non, then we select b as something like this, right? Now it should work as expected. So if I copy this code here and try to run it, except that I have some kind of tabbing issues, of course, with the Python. Okay, I will just write it here. So the non, if b is non, then I want to have b as this. Whoa, not like that, but as this one, right? And if I run it now, I get the expected output, the 3343, as you wrote in the very beginning. So expect more small pointer tasks like these, because if you are a good programmer and you say that you are 8 and 9 as you did in the first session, then these tasks should be really easy for you. So, but I like that you're honest. That I like. And I like that you don't try to quickly write the code and actually think with your brain. So all of those things are really good ones. So, okay, let's move to the next task. Just a second, where is my dashboard? So the next task in the Google Classroom, please pick up the template for the robot arm. So this template will be the task 3.2. So the 3.2 task, I am currently enabling it. So the 3.2 task, I will show you it as well. So the 3.2 task will give you a template like this, and it will also have the rotation matrix in 2 dimensions. So just to make these equations a little bit easier today, I chose to go back to the 2 dimensions, not 3 dimensions. because otherwise it will be maybe too difficult for you now. So the first task that I want you to do is actually to create a visual like this, where you have just one arm of the robot, and with a theta angle. From the angle is calculated from the upwards pointing vector, and the length should be like just like 2 units. So this right now will be just a stick, like without the other part of the robot. So this is just the first task for you. So let's start by examining a few questions. So first, is template, do you have access to the template? And then, did you download template and task is clear? So plus minus. And also, let me show you around a little bit. So here you need to implement the rotation matrix. The theta 1 and theta 2 angles are already given you, so from the degrees to the radians. Then there is a length of the joint, so that's also ready for you. Then if you press escape button, then you can escape this window, right? And then what you need to do is add here a joint. So the joint should go from the 0, 0, so basically let me show you the anchor point. So joint, let me see, so joint should go from anchor point to upwards with length joint with angle theta 1. So I see pluses coming in. That means that you understand the task and know how to do it. So please submit the task when it's ready, and then we'll move to the next task. So this right now, what you are doing, this is called forward kinematics, because you're just constructing the robot arm and not really calculating it backwards, just constructing it forwards. So please do this equation then. And afterwards, we will do the next part. Okay, I will give you time to do this, and then we'll move on. Well, I will drop also the template here in the chat if somebody don't have access to the classroom watching later. By the way, for the translation, this time you can definitely use the standard affine transformation. So that I mean is you can just add the vector of the translation. So you can use also a translation matrix, but like because this is a two-dimensional stuff, it will not the three-dimensional, and we're working around the z-axis here. So I would say that it's better to use affine transformation, so I will show you that as well in a second. So let me see. So if that would be position, I will write some equation down, maybe that would be clearer, but in general you can just plus the translation vector. Just a second. So what I propose you to do is to use the rotation matrix dot your position, initial position, right? And then add the translation vector. So basically the idea is that you use the rotation matrix, position, and then add the translation of the joint, basically. So yeah, so I will add to the Jamboard. So this is called affine transformation. Also used constantly, also known as linear transformation. So this is used constantly in deep learning, like you use it all the time. So copy as image, adding this here. So I just forgot to mention that in 2 dimensions the translation matrix is not necessary. By the way, it depends on how you construct it, because the equation might not be exactly the same way as you need it. Because remember, of course, that you need to think yourself, like when you translate something, when you rotate something, all of this is chained together, like it's a chain, right? So you cannot just like apply any equation and expect it will work. You just need to think about it, how to construct your equation for this very simple task. So because no one has yet submitted the code, maybe I will help you out more. So I mean, the equation can be like I wrote it before, but it can be, of course, like anything. So the position itself, for example, so the order can be in different order. So let me show you. So here, if this will be some kind of B vector, PB, I will add this quickly to the Jamboard. You will see it in a second. So P plus t like that. Just writing the equation, adding the equation to the Jamboard. So maybe this case you should do something like this. So again, the order of the transformations is important, right? So you cannot just use the same order for every task. So here, in this case, the translation comes first. So translation first, and translation first, and here the rotation first, basically. Rotation first. So I'm just trying to show you that the order is important. You don't need to use translation matrix. This is a really simple task. Just just try to implement it so you get this kind of picture. And when you're ready, then submit the task, and we'll see who's going to be the first one. Now nobody has yet submitted the task, it seems like. Let me check. Yes, currently nobody has finished it, so we need to wait. Okay, so again, thank you for asking the questions. That's why we're all here. So those p vectors, they are vectors. So let me try to explain more about them. Just a second. So I will share my screen. So if you don't understand notations, that as well is something that we can talk about. If you don't say anything and then are unable to complete any of the works, that is worse than just asking questions. So here the notation is following. So the large letters are the matrices and the small letters are the vectors. So here, for example, in our case, we have two vectors. So let's see. So this is p. So the initial p could be, let's say, the zero vector, like that. So this is the two-dimensional. Oh, something strange happened. Why this is happening to me? Oh, sorry, and. Okay, cool. Okay, cool. So this is a 0, 0 vector x0, y0. So if I copy this one and drop it in here just to explain. So this is one thing. Already you're giving so much information now. Like this is like so basic information. I'm just laying all on the paper now. So you should be able to implement it quite fast now. So here, and then the t is some kind of like this translation stuff, right? So, and we want to translate it actually in upwards direction by the length, right? So this will be 2, or in this case, what was the name there? Some kind of length. I don't recall. It's basically some L vector, or let's keep it as 2 because it was 2, I think. So basically this is your other vector. So now all of your stuff is laid out in front of you. So hopefully now you get it. What is all of those t, p, and so on? So they are just vectors, right? So two-dimensional vectors. It doesn't matter actually what is inside them right now. It's just the method, basically how you should approach the problem. So if you did the homework, you did this all the time, by the way, because in the homework you should have like move around the objects and chain together transformations. So this is just a very simple task. So if you have any something not clear about this still, then ask very specific question and I will answer it. We still don't have any completed tasks, so like in order for anything of what we do to be valuable, we need at least some interaction here. So we'll wait for somebody at least to finish the first task. So we have one first winner, the Gins. So I will quickly check his code, and let's wait for a few other people, but we will need to probably slowly move on, because otherwise, like, we got stuck on these simple tasks too long. So if I run it again, so I will try to run the code from Gins. Okay, seems great, except I think the angle is on the other side. So I mean, the angle for Gins is not like in the picture, it seems like. And if I look at the code, is it like in the picture? I think it's not like in the picture. So if I will check his code a little bit, I move around a couple of things. Oh yeah, so the code is not really that perfect, but I think like the Gins code will be purified when he will make the next task, because he will see that his original implementation is not that great right now. But of course it does the job in some manner, so it's not great, but it does the job, so that's great. So we have first person finished this task, and while we're waiting for other people finishing this task, and also to help out Gins to fix his code, is that I will open the task 3.3. So 3.3 task, again, forward kinematics, not yet the inverse kinematics. I think most likely we will do just like a quick intro today for the inverse kinematics, because it seems like you're a little bit slow right now. Hopefully you will get more comfortable with Python as we go along, and hopefully that's mainly Python, not the lagging of the mathematical knowledge. But even if that's the lagging of the mathematical knowledge also, I hope that you will get better. So I opened the task 3.3, and Gins will see that his code is not good for the 3.3 task. So he will need to probably fix the first task code, because 3.3 task wants you to make the two segment robot arm, so with the theta 1 and theta 2. And I want you to specifically notice that here the theta 1 is aligned from the top vector like this, with some angle here, right? And then the next is aligned from this one with the 10 degrees here. So you see that this is not like just like very simple task where you just like calculate 10 degrees from whatever, but this is relative to the next joint. Because if this is a robot arm, right, you cannot just like have some arbitrary angles, they should be chained together. So this is the next task for the robot arm. This will be the task 2. Also, I'm just realizing maybe you are so lost that you cannot know how to do this at all. So and I see the comments that is too difficult. Okay, so so I will give some hints more maybe. So let me help you out with at least the task 3.2. So Gins was the first one finishing it. Let's double check if somebody else is successful on this one. So this is again very simple task. So okay, I will go back to the code now. Okay, to the code, and just in a second, so I will help you out with the first joint. So we need to implement the rotation matrix. So that's the most easiest part, right? That is something that we already did multiple times. And so this should be like just with the closed eyes you can do this. So np cosine of the theta, and then smp sine, right? Theta, and then we calculate the rotation of the np array of the multiple vectors here, where there's like the matrix. Of course, the multiple vectors in the row, they are matrix, right? So minus s minus c, c s, like that, right? And then we want, sorry, a mistake, c minus s, sc, and then the rotation matrix, right? So this is the easiest part, right? We already did this multiple times. So I will drop in this in the Jamboard just in case somebody is really struggling. So the good news is that like in a few other lections, the workshops that we have planned ahead, we will keep repeating a lot of these things, like for example the rotation matrix and something like that. So if you repeat it many times, probably you start getting it, hopefully. So so there are the questions about the 7th grade. So I think this is not actually the 7th grade stuff. This is calculus or augstākā matemātika. So I think this is something that university should cover, in like to teach you some of the basics regarding this. You can also find the books. So actually, this is not the augstākā matemātika calculus. This is linear algebra. But I was planning to do the calculus today. So basically, okay, I will type in the chat some of the things. So you can try to find some material regarding linear algebra, right? The calculus, read up on those examples. So I will try also to kind of explain those things repeatedly. If you ask me precise questions, like for example, Armands was asking about the vectors, and I can give you like immediately what it means. But if you just say that you don't understand anything, then it kind of don't help. But if you need to have precise questions. So here, the rotation matrix, that's fine. I know in some other courses that I'm leading, I know that some of the guys are just like asking all the time some really dumb questions, like they think, and that is something that is kind of helpful. We did learn in the bachelor study, so that's great. So I mean, that means that you can refresh your memory, but in general, like with deep learning, this is something that you use all the time. So if you don't understand this stuff, then it's you're like a blind man, like just trying to put together some Lego and thinking that it will work as you expect. So you still need to understand all of this math. So here, the joint part, then just to creating the first arm, the Gins did it a little bit not like completely correct manner, I think, because but it's like trivial thing, so you will see it in a second. So one is that we need the joint starts from 2 lines, right? From 2 points, I mean. So the first point, of course, is the anchor point, right? So we don't modify anchor point at all, right? Because this is the first point in our line, right? So then the second point is the joint, and this joint we will rotate. So we need the rotation matrix actually. So let's calculate rotation matrix here, R1, because we'll have actually, as you see, the 2 rotation matrices. So this will be the first one, theta 1, and we will dot product it with the translation vector. So the translation vector is so it is np array of so it's pointing upwards, right? So like that, it's pointing in upward direction, and it is with some kind of length. So the length is the length of the joint, like that. So now we have calculated the position of the second joint. So and then if I add this to the append, the joint like this, we should be good. So you see, like 3 lines. So I don't ask you to do like crazy amount of work. So just like really few lines of code, and that's it for these small tasks. That's why I say these are small tasks. They are not huge tasks. That's why we do them live, and we try to understand how to do them well. So here we have the perfect example as it was asked in the original task. So I will add these lines to the with escape. You should be able to close it, but it's kind of not closing anyways. So I will add these lines to the Jamboard, and then probably we need to move on to the next part. Otherwise, we will just waste all of our time today. We don't have yet left so much time, and we need to talk about some of the things that will be covered with the inverse kinematics. So I'm adding this stuff to the slide number 4, and you can finish it later and then submit the code for the next segment. And meanwhile, we will start digging into derivatives, so the calculus. So let me kind of so what we could do, we could share this code. Could see the latex. Probably I need to share my latex stuff, otherwise it might be too difficult to explain. Okay, so let's leave it like that. So now imagine that we have this new joint, right? So the last joint here is our tip of our finger of our robot arm, right? So this is what we have. And now we also know the target position. So let's say that the y prim is so here with our equation, this is r1 dot product c dot by this what was the notation p matrix. So dot product by by this guy. So 0 0 2 and p matrix like that. So this is our stuff with regards to, maybe we can even make this a function. So theta 1, right? So this we can make it as a function maybe. So theta 1. So this is our tip of the finger. So if we would have like these 2 lines, that is the next task, then we have the tip of the finger at different position, right? It will be chained together with more equations. So here, then the target vector, right, will be our y just without the prim. So this is our target vector, and the target vector initially is set to be -3 and 0. So we can again use my notation here, -3 and 0. So this will be our target vector, just in a second, like that. So we have the tip of the finger and our target vector. So we need to somehow change the theta here so that we would go step by step closer to our target vector, right? Of course, right now our target vector is not reachable because it's -3 and we have the length of the arm as 2. So, but that doesn't matter. We can try out to reach it as good as we can. When you will add the second part of the equation with the second joints, then you will be able to reach this properly. So if I copy these notations so you can follow up with the code later. So I will drop this in the fifth slide. So the next part missing here is some kind of evaluation of how close we are to the target. So let's ask a question. So how can we calculate the how closeness to the target, so I see also some question regarding the joint. That's fine. Not seeing the question actually. So Armand, if you want to specify the question, then I can help you out. But I'm getting an error. Input operand 0 does not have enough dimensions. Input operand 0. So it seems like in your case that it might be possible that your R1 is not in the shape of 2 by 2. So my question is still in the chat. So how can we evaluate the closeness or the error basically of the y prim and y? So that is, we need to minimize the error between these two vectors, right? You want to make sure that the robot arm is as close as possible to the target. So that's my question still in the chat. But meanwhile, I will try to answer Armand's regarding the this error that he has. So here, if we add the breakpoint, for example, at this line, and we run it, you will see that you can check the shapes. And of course, you cannot multiply, do the dot product with any shape you want. It must be very specific type of shape. So here, the shape is, if you look at the shape, it's 2 by 2, right? And the vector that we calculate here on this line, if I just copy, drop it in here, it's a dimension of 2, and that's why it works together. So if you have different kind of dimensions here, it will not work. So please check on that. That hopefully should help you out. So maybe you have some mistake on the this rotation matrix. So that's regarding the question. My question still holds with regards to this stuff. So it seems like that I don't see any answers in the chat regarding some kind of calculation of the loss or the error. So in the deep learning, you always use the term loss. So the term loss actually means the error, basically. So how big is the error? So let me try to then show you stuff, because this is again very basic stuff. If you do the physics, right, some course with physics, you also should know the ways how to calculate some of the errors, right? So let's see, this will be the one option. This is not the only option. There are a lot of options how you can calculate the error. So let's see, so this will be the mean square error, and this will be the equation will be frac 1 over n, and this will be the summation of the n's, right? So let's drop it in like that, over n's, right? The n's are the dimensions. We have only 2 dimensions, so maybe even the best way how to explain it, oh, I just don't want to like mess up my equation, but basically the n's are the dimensions, so 2-dimensional stuff right now. Then y minus y prim and squared. So very simple equation, except I forgot something here. What is this? Missing frac sum n. Where is my problem? Ah, okay, here. I don't know, I didn't want to use the frac when mat call. Okay, cool. So now it will work. Yes. So this is the equation that we will use to evaluate the error of our position. So let me add also some notes. Maybe again this is too complicated, but hopefully not, because this is really simple. So here this one is the end of the finger. Oh man, what is happening here? So end of the robot arm. So with one joint, with one segment, with single segment. So we will have to do this with 2 segments, and maybe I will ask you to do this in home with the 3 segments or whatever. So and this one is the target position, right? And this one is the error. So error of just error of the positions. So I see actually in the classroom that we have a second winner, I guess. Let me check. So the second winner is Kristaps. Well, I will later check his code. And for the 2 segment part, nobody has yet done it. So we get the closest to the target by calculating the length of the vector. Right, yeah, the length of the vector. So actually the mean square error in this case, we want what we actually want is one error as single scalar value, metric or value or metric. If you look only at this part, so what Armand is saying, what is correct. If you look only at this part of the equation, just a second, transparent, then this part, of course, can be just a distance, the Euclidean distance, right? So that is simple stuff. But we want some kind of metric that we can use to evaluate the closeness to the target with just one single value. So we want to say this is good position, this is bad position with just one number. The 0 would be a great position. So if we get value 0 means perfect position. So far, hopefully that's clear. So we have a way to evaluate the goodness of the position, right? So let me ask in the chat, is it clear so far? If it's plus minus, if it's not clear, then please ask exactly what part of these equations is not clear. By the way, this stuff is exactly the same as in deep learning. So this loss function you will use all the time for regression tasks. You can use it for reinforcement learning. For there's almost every single task you can use the mean square error. So great to see that some of you saying that the 2 pluses that it's clear so far. If it's not clear so far, please try to type in the question which part is not clear. So then what we want to do, I will quickly try to give you a brief intro of what we need to do then. So we want to bring the y prime vector as close as possible to y vector, right? So to do that, the correct way to doing this is using the derivatives. So derivatives of the loss function with regards to our variable, and in this case the variable is the theta. So what we want to do is to calculate the frac of loss the mat call L MSC of with regards to d. This is not a partial derivative yet, so this will be the theta 1 with regards to this one. So we want to calculate this equation. Oh sorry, there is something missing here, the mean square error like that. Yeah, so we want to calculate the derivative of the theta. So I hope that the word derivative is not alien to you, because again, this is like very basic stuff of calculus, and basically this is a backbone of all of the deep learning. So you talk all the time in regards to the derivatives. So here there is one derivative, and we need to calculate, of course, that. I hope that you are able to do that. And then when you have that derivative, so maybe even how could I say? So the derivative is if you have a velocity, then the derivative would be acceleration. So this is just like direction on which we need to go to. So let me add some small explanation. So derivative is in this case a direction on which we need to change the theta to minimize error. Okay, so this is the purpose of derivative in this case. So this is a direction kind of your function of that particular variable. So that is one case. Then another thing is the another thing that we need is then what we do with that derivative. So with that derivative, we can very easily change our theta. So that would be, in order to go to the minimized theta, we would do the following. We would get our theta prim, theta minus alpha times c dot this, like that. Yep. So we will do following. So do any of you know what is the name of this algorithm for changing the theta? So, and alpha here is the step basically. So alpha is the step at which we change value. So I mean, if we have a large step, then we can jump with large like leaps. If it's a small step, then we can change the value very slowly. So it's like kind of like a speed. So do you know the name of this algorithm? So using derivatives to change the variables. On using the steps. So do you know any idea what is the name of that algorithm? Plus minus. So if like I mean like not the plus, but then just type in the name of the algorithm if you know it, minus if you don't know it at all. So if you have some questions with regards to these equations so far, you can also ask questions. So you can already predict and see what we need to do here that is missing with the question mark. You need to calculate the derivative there. So let me know the answer. Okay, we have two minuses. So this is super common algorithm also in deep learning and in other fields. So it's called stochastic gradient descent. So in Latvian, kalnā kāpēja algorithms. So stochastic gradient descent. That is something we use all the time. And let me illustrate what I mean by that. So if I go back to the code, so we will need to quickly make maybe a small example so that I can illustrate it. So import, so you don't need to write it right now, I'll just make it for you. So numpy as mp, so it's just will illustrate the idea. So this will be that one, and then we'll need import matplotlib pyplot as plt, and this will be the so we will generate the error. So our error, so the error is actually this thing y minus y prime, right? So this is our middle part. So we will generate that one, mp lin space of so the lin space was the first one, is the start stop, so minus 10 plus 10, and with this we want, let's say, 100 samples. So these are all possible errors. What does n? Okay, thank you for question. So the n is just the number of these pairs. So if we working in this example that I show you now, we have one-dimensional y and y prime, and we don't have one-dimensional error here. So this is one dimension, right? But this is not the case for our robot arm, because robot arm have, for every point we have two dimensions, and we need to sum them and divide them by n. So that's why there is this sum and the n division. So that's just the number of dimensions or number of the samples, doesn't matter. So here we have this one. Then the mean square error is the error squared by 2, right? So far so good. Then plot show MSA. Then plot, I mean not show but plot, and then plot show. Hopefully it will work. Yeah, cool. So this is our error function. So I will try to explain it like quickly, just a little bit. So the error function here, this is mean square error. So if we have the, let's say, so this is actually coming from, interesting, I was asking minus 10 to 10. Okay, it doesn't matter, it is actually minus 10, but the bottom axis looks a little bit funny. So the bottom axis looks funny. I know, because I didn't give the bottom axis, sorry. I will quickly sort this out. So if we add the error like that, now it will look properly. Yeah, that's much better. So that's much better. So on the x-axis we have the error, on the y-axis we have the scalar value of our error function, the mean square error, right? So if we have the error of minus 10, then we have 100 scalar value of error, right? If we have the error of plus 10, we get the 100 again. If the error is 0, then we get 0 here, right? So that's great. By the way, there are different kind of shapes. So this shape is like a parabolic shape, right? So very nice, smooth, but you can have all sorts of loss function shapes. So now let me illustrate the idea. So if in the very beginning our, let's say, the y minus y prime is located here at let's say the 5, now we get the error. Now we get the error of 40. Then we calculate this delta, I mean the d theta, right? The derivative of theta, and apply it to get a new y prime. And the next time the y prime is now going in direction of the 0, so it's here. So after changing the theta by using the delta, not delta, but the d theta, we get a loss error closer to the 0, right? So if you look here, you see that I'm changing it with the minus sign and with small step alpha. So, and this small step alpha is actually this green jump alpha, right? So, is it clear so far? Is it clear so far? Plus, minus. If not clear, then please type in exactly what is not clear with this algorithm so far. I'm just reminding you a little bit that the purpose of this is that we want to calculate all of the angles for that robot arm, so we can reach the goal of the red dot on the plot, and we reach it just by using the derivatives. So is it clear so far? Plus, minus? So we don't have actually that much time right now. So I really appreciate if you can help out with some feedback. So I see Kristaps is saying it's clear, that's great. Gins is saying that's clear, that's great. Hopefully others who will watch this later will not regret that they are not joining online right now, because as Armand is asking questions, that's great. Then we can kind of work out some of the issues, so you don't need to have private tutor to finish this course. So that would be great if you just ask more questions then. So I see two pluses. The robot arm is going to move in the plot, is not going to get to the desired place after one iteration. That is correct. I like this question very much. So Kristaps is saying that with the one iteration we will not get to the desired location y. This is absolutely correct. So one iteration with the alpha jump gives us still the error. We are not getting to the exact location. So let me ask you another question. So here I will use the blue color. So here I will show you so this was the jump here. Then let's say the next jump will be here, and so like where is going to be the next value? So now imagine if we are somewhere around, let's say 2.5 here, and we are moving with this kind of step. So if you are very close to the 0 now, let's say some 2 or so, so where will be the next step? I will write some options. So the next step can be let's say so the next step can be here A, or here B on this side. So what do you think? Like, will it be A or B? So next iteration, A or B? So what do you think? What would be more likely location, at A or B? If you're right now at that blue dot. So we're now here. Again, very simple logical question. Let me know. So we have 2 votes for A. Wait for some other ideas maybe. I like how Kristaps is suspicious about every of my questions, so that I like to do the trick questions. So in general, the answer A is correct. So I'm not asking all the time trick questions. For the difficult things, I will not ask that trick questions. Like it's difficult enough. It's actually, this thing is not difficult, but still. So now we are at this position, right? So the next question is, where will be the next point? So the next point could be here, A, or B. So again, let's see. So where will be the orange point next, A or B? Funny answer. If we coded it right, then B. Right. But I'm happy that at least those of you 4 people who answered, you all answered absolutely correctly. That you hopefully you got the idea that we want to reduce the error, right? You want to reduce the error. That's why we will go to the towards the 0. So the next point will not be upwards on the right part, but it will go down. So it will be here, and it will be in this direction. So the idea is that we will try to get to the 0 as close as possible, but we will oscillate, we will jump around that place. And the way why we will jump around it is because this the derivative gradient will be always pointing to the 0, whatever on the which side it is, okay? But it's really hard to get the absolute 0. So I will drop in this plot also here. Like this, right? So this is what we want to do. It's because A is surpassed 0. This is trying to get back to 0 as so yeah, we're trying to get there. And because basically the shape of this function, the parabolic shape, is because this mean square error is parabolic shape, right? So far so good. Then let's split the task in multiple parts so I know a little bit over time. So we'll definitely need to do this tomorrow properly, and then we can only move to the deep learning stuff. But today we'll start giving you some material that you need to start thinking for tomorrow. So here, let's split the task in 2 parts. We can start calculating derivatives not all of them immediately. So we can calculate them step by step. So let's see. So if I have derivative, actually I probably need to somehow copy that equation so it's close to you so you can answer my question. So here there is the equation of the mean square error. Oh man, this is, yeah, actually this was what I wanted to show you. So I want you to calculate, basically we can even simplify it a little bit. Let's simplify it to this point. So let's see, there will be frac over this guy, and with the d of y prime. So if you remember the calculus, you can use the chain rule to split out the parts of the equations for derivatives. So here we again will use the chain rule, but let's look at only this equation. So here, if you look at this equation only, so what will be the answer for this derivative? So can any of you give me the answer? So what is the answer for this derivative plus minus? So not plus, but you can type in the equation, whatever you can. You don't need to write in LaTeX. You can write it just in like a simple form. I will understand it. Or you can type in minus if you don't get it how to do this. So if you don't ask me or interact with me, I will assume that that you understand everything and just keep moving, and that will be not beneficial for you. So that's why I really highly suggest that you interact with the chat. So any ideas? Plus, minus, not getting it? Okay, I like that at least somebody is trying. Yeah, you need to derive the formula, that's right. So far, I don't see any correct answer yet. I think, yeah, so at least I see Amo is posting something. So maybe, so Amal is missing something in his answer, but still, like Amal is the closest one right now, but it's again maybe not that trivial. So okay, I'm not sure about your capabilities with regards to derivatives. Maybe let us check with some simpler example. So let us start making some function. So for example, there will be a function of let's say, let's split it in two parts. So the function will be of x something, and this will be, let's say, 3 plus, again, let's make it in kind of rotation stuff. So I see two answers, very similar, like, but they are both not exactly correct, because the derivative of that one, so they are correct in a sense that if this would be everything that we got, but the idea is that the y prime is coming from another function. That's why we cannot just leave out at the end the y prime itself. So it would be probably good to multiply also the derivative of the y prime itself, but in general those two answers that I see in the chat, they are kind of correct. but let's get to them step by step. So just let's do some basic example first. So let's see, 2x of let's say 3, and let's see then the f of x. But you're right about basically that one. I was just expecting that you would add also the multiplication of the inner part, but that's fine. So here, let me show. So can anyone give me answer on this one? So what is dx here? What is dx dx here? So, oh, sorry, I dropped my code here. So I will copy that to the Jamboard, and I will also add a note that this is just an example, quick example of some of the rules. So there is like a constant, there is a power rule, there is multiplication rule, like really simple ones, and then I will quickly today show the derivation of the mean square error. But in general, those answers were not so bad. Yeah. So Amal is giving the correct answer in regards to if this is a function, then there would be something like that. So this is just, let's add here just a small example, and here on the top part we have a real problem. Real problem. Okay, so I see in the chat that you're good with this, so I'm happy about it actually. So that means that you should be able then to compute the robot arm movement. That is great. So for those of you who are not catching with this up like very well, I will quickly show you the way how you get there. So so here there is the idea that the constant rule means that all of the constants are ignored. So basically, the constants are turning as zeros, right? Then the multiplication rule says that we leave the 2 untagged, right? Then we multiply that by the power here, like that, and then we square it by not square it but power it by n minus 1, like that. And so if I run the equation, so I see it like this. So, and then we get the answer that all of you posted, and makes me feel good that you understand at least some of the very basics, so that's great. So that is the answer then, right? So this is good, and just the last thing for tonight, then let's look at the previous example. So the previous example, if I go back and I asked you to do this one, right? So here the idea is a bit tricky. So the tricky idea is that I like that after I give the simple example, somebody is starting to post some other ideas, but Armand actually gave the correct idea before, I think. So here the idea is again the very similar one. So only difference is that that here is the power, and and this one is tied together with the inner part. So again, I need to somehow show it because you cannot just use immediately power law here. So if you would use the 2 minus 1 here in this part, you cannot use the power law here. So cannot use power law directly because the y here, this guy, is with some other operation here. So there is a minus operation here linked with other mathematical operation. So you first need to get to this guy. So basically you cannot just directly do that derivation without somehow eliminating that basically the square here. So the elimination of the square happens with a chain rule, and we will use a chain rule a lot. So that's why please get up to speed with regards to chain rule. So with the chain rule, the idea is very simple. We will just derive parts of the equation and then multiply them. So here, the chain rule would look like this. We would use the upper part and derive it. So by the inner part. So the inner part is this one, and then we would multiply it c dot by the outer part. I mean the inner, that was the outer part, and the inner part is what we want to achieve. So I have those y i's. I unfortunately forgot to remove the i's there, but that doesn't matter that much. So like that, and then we want to derive the inner part, right? So let me check if I don't drop some of the parts that I need. So this will be that part, and here will be the y prime. So just be careful about the answers were correct, I think, but let's see. So okay, what is this about? So okay, cool. So we have the chain rule here. So that guy would produce as so the first one should produce as the output the idea of that the classical rule of power rule. So basically, I can also try to maybe explain it a little bit in different way. If for some of you this is confusing, you can like signify these two items. Actually, you can even signify this item so as some kind of temporary variable, like for example b or something. So you can think of this as a b squared over the db, right? And on this side, maybe it's not useful, but basically you can derive it in this thinking like this, right? In your mind, you can just substitute with whatever variable you want. So here the answer would be, of course, like the 2 comes first, right? Then this guy is 2 in the 2 minus 1, like that. And then here we have c dot of the first part that we have as constant that we eliminate, and the second part is minus frac over y prime over d y prime, like that. So now we have that part ready. So and then the last thing missing here is the actual answer, and then we'll check with what you sent before. Seems like that you are a little bit off, I think, because there's a prims there and I don't see minus sign in the front, but minus sign is super important. If you don't have the minus sign correctly and the order correctly, then you will not get the desired result at all. So that is something that you need to keep in mind anyway. So c dot like this. So that's why I need to be very careful about how you derive these equations. So okay, I will try to copy this as a PNG, drop it in here, and make this example smaller. So now we have a derivative over of the dy here, and this is this one. And of course, like tomorrow, we're gonna try to get to the derivative of theta here, and you can start looking at this at home. So the best thing that you could do is try to submit the homework with actually working example. If you cannot submit it with the working example, then you would be able to do this tomorrow. So the idea is that you need to somehow calculate this d theta and then modify theta step by step to have the zero error, and you will get this nice result that I showed you before, where the robot arm is moving towards the direction that we want. So I would quickly remind you how it looks like, and then we'll end the session today, and we continue tomorrow. I will think about what kind of homework can I set up for this session, and then the next session will have different homework. So if I run it, I will show you tomorrow how to derive it correctly, so don't worry about that too much. But if you can do this yourself, that would be excellent. So the code looks like this. See, the robot arm is trying to get to the red point. I can place the red point whatever position I want, and it will slowly try to reach it. Even if I point this very long distance away, right? It will try to slowly change the thetas. You can see that the loss is reducing all the time, and it will be like a straight line for some longer time period. And if I drop it in here, it will try to now change the angles like this, and you see beautifully that it tries to change the inner part of the angle, and slowly gets to the red point. So this is what we want at the end. So for the first example, I want you to make it just with the one line, and then you can do this with 2 lines, and then maybe with the 3 lines. So that's it for today. I hope that you can catch up with the mathematics that I guess some of you are a little bit missing. I also hope that you can read up on Python a little bit, because it seems like that we got from level 8 of knowing Python to the level 1 for some of the people. So all of this stuff probably not so vanilla as usually. So let's meet tomorrow. Be prepared for more maths, and at the end, the good news is that then you can make actual proper deep learning AIs. So